Hello. The topic of today's discussion is the quality of service in networks, and we are very specifically talking about Diffserv, that is the differentiated services architecture. When we are talking of QoS, we are talking of quality of service, and when we are talking of networks, we are talking of IP based network. The largest of the IP network is obviously the internet. The internet has its roots in the ARPANET. The ARPANET was a project of US Defense Agency for Advanced Projects, and it was established in 1960s. The basic objective of this project was to have the network designed so that it could survive the bombings. So a network where the end systems are working, and even if the part of the network is gone, is bombarded or they are lost, then the end system should be able to communicate. The people who are designing this type of network, they opted for a mechanism called connectionless datagram protocol. And in case of connectionless datagram model, the packets, they were routing individually to the destination. Every packet was required to have an address, and the router or the intermediate devices, they were required to check that address and then forward those packets to the destination. This mechanism was very flexible, robust and simple. The applications which were running on internet were like email, the file transfer protocol, and the resource sharing, the remote login. For these applications, the internet was good enough. When the internet was being used by the people in the business and the arrival of www, that is World Wide Web, the things changed in internet. We were having different type of applications which required different treatments. So the internet or the use of internet for different application, it posed a lot of challenges. One of the challenge was to ensure the performance for the application, that is the performance assurance. Different applications, they were having different requirement, like interactive chat application was having a different requirement from the file transfer protocol. So the different performance issues, we were expecting that the interactive or the real-time packets, they should not be kept behind the large file transfer protocol packets, and it should delay these packets. So this means there was a need to provide the different treatment or to ensure the performance. The another challenge was to have the service differentiation. The internet used to provide the best effort services. It treats every packet in the same way. For internet or for the network, there is no difference in a voice packet or a data packet. But the present day application requires that we should be able to have differentiation in these packets. So this means there is a need to have the quality of service, and the network which offers performance assurance and the service differentiation is called quality of service. Now the quality of service has been defined in different ways by different organizations. ISO, the International Standards Organization, has given one definition for quality of service, and the Cisco, which is a lead manufacturer of networking devices, has given a different definition. The ISO says that the quality of service is a set of qualities which is related to the collective behavior of one or more objects, whereas the Cisco says the QoS refers to the measure of transmission quality and the service availability of a network. So we can see that the definition of quality of service by the Cisco focuses on the networks. Now, what are those different matrices? what are the different matrices or those parameters which define the quality of service? There are 4 different metrics, 4 different parameters which are used to describe a packet's transmission. That is a bandwidth. What is the bandwidth which is available to a packet when it is moving from the source to the destination? Then another parameter is delay. Delay is the time taken by a packet from the source to reach to the destination, and this delay comprises of several delays. That is the propagation delay, the serialization delay. The propagation delay is the delay which the packet takes to go from one end to the another end. The serialization delay is the time taken by the packets to put on the transmission lines, and besides that there are other processing delays which are occurring at the different routers. So there are different types of delays, and the collective and the total delay is the sum of all of these delay which the packet experiences. The another quality of service parameter is the jitter. The jitter is the difference in the delay of different packets, or in the inter-arrival time of different packets. If there are packets, suppose there is a voice application which has generated 4 different packets of the same size, and they have been sent say after 10 milliseconds from the source. Now because it is passing through a network of different routers, the packet at the receiving end the first packet which is received at the receiving end may take 20 milliseconds, the third packet may take 40 milliseconds, the fourth packet may take 50 milliseconds. This means there is a difference in the inter-arrival time. The inter-arrival time of 20 milliseconds is different now at the receiving end. This is called jitter. So for the applications, the real-time applications like voice or video applications, the jitter is not tolerable. The another quality of service parameter is the loss. The packets, when they are crossing through different equipments or the different networking components, they are required to be put in the different queues, and when there are a number of packets which are there in the router's queue, the packets which are followed will be dropped. This means there will be packet loss, and there will be packet loss because of the congestion. There are certain mechanism which has been devised which can forecast that there will be congestion in the network, and before the congestion they start discarding the packets. So the packet loss, so this can also be one of the reason for the packet loss. So with these 4 different parameters, now let's see what has been done so far in the internet quality of service. So the forefathers of internet, they had envisaged that the people in future will require the quality of service, and for that they had provided a type of service field in the IP header. For the application like email, file transfer and remote login, this QoS field was not used, but for the application, the real-time applications or the voice and the video applications, the TOS field was used, and then we had seen the different changes in this particular field. The different bits of this 8 bits field was modified by different researchers in different times through IETF. IETF is that body, that is Internet Engineering Task Force. This is one of the body which standardizes different architectures or the protocols, and this has standardized the quality of service protocols. Now when the quality of service was thought of in the beginning, at that time it was focusing only on the hosts. So because the application at that time in the early 80s were related to access the file access or the emails at that time, or the remote login, at that time the overhead of the TCP was too much. So the efforts were made to reduce the overhead. So different people suggested different compression mechanisms so that the headers could be reduced in size, and then the people started thinking that the congestion is one of the reason which causes the degradation in the quality of service. So the people offered some of the mechanism for congestion avoidance. The slow start, fast recovery, fast retransmission, they were some of the mechanisms which were used by the researchers for ensuring the quality of service. All these efforts, they did not allow the end-to-end quality of service until the routers, which are the important component in the networks, are taken into the consideration. The routers at the time were using the first in first out mechanism for scheduling the packets in their queues. So there was a need to prioritize different types of packet and have different type of scheduling for these different applications. Now these end-to-end quality of service has been standardized by the IETF, that is the Internet Engineering Task Force, and the IETF has provided us with 4 different mechanisms, and the work is in progress. The IETF, it works in such a way that it takes the requirements from the researchers. It works on the latest topics of research or the new problems, and it encourages the people or the researchers to find solutions to these problems. The proposed solutions which are offered by the researchers are put into the website of IETF, and then the people from all over the world, they can give their comments on these solutions. So the IETF has proposed 4 different mechanisms for ensuring quality of service. One is integrated services, the another is resource reservation protocol, RSVP, the third is the Diffserv, differentiated services, and one more is the multi-protocol label switching. In case of IntServ, the focus is on per flow. So the applications which require the quality of service, they are required to inform the network in advance, and once the requirement has been known to the network, then it ensures, it tries to it tries to convey this message to the different devices which are there in the network until to the receiver. If the resources are available in these devices and at the receiver end, then only these resources are given access to, or their request is entertained. The IntServ model, it uses 2 different mechanisms. It uses a path message to reserve the resources from the source to the destination, and the RESV message which is being used by the receiver to ensure the reservation. So we can see that in this diagram there is a source, there is a sender which sends path message. All of these devices, the routing takes place, and then all of these devices, they book the resources, and the receiver, when it agrees to all these requirements, then it sends the RESV message for using the same path which has been used by the path message. Now there are a number of issues in the IntServ model because it expects all the applications to book the resources in advance. So every router is required to identify and classify the flows, and then they are required to maintain a queue for each and every flow. Besides that, the scalability is one of the important problem, because in this case we are maintaining so many of resources, we are maintaining so many of state information about each and every flow. So it is not possible to have the maintenance of these states by incurring more cost complexity. So this model was not considered to be an appropriate one for the internet, and then the people offered another mechanism which is called differentiated services mechanism. And the good thing about the differentiated services model is that it is better than the best effort and it is more scalable. So whatever problems we had in integrated services, that those problems have been removed in the differentiated services. And this mechanism is a simple method. So in case of IntServ, we were booking the resources in advance, but in this case of Diffserv, we don't need to book the resources in advance, but we can do it in the fly. So we don't signal, but we provision. So the resource requirements are being checked. The different packets are given different treatments. So for that, there is a need to classify the packets. So how the different treatment can be given to different packets? So you need to first know whether there is a packet which requires different treatment, and for that we are following a process which is called classification. And the classification, it is done at the edge of the Diffserv network. In a Diffserv network, when it is being created, there are several nodes, and the nodes which are at the boundary of the Diffserv network, they are called the boundary nodes, and it is the responsibility of these boundary nodes to provide the classification of different devices. Once these packets have been classified, that is, a router now knows that this is a different packet which requires special treatment. Now that special treatment is also required to be given. Now how do we give that? For that, we are using a mechanism called provisioning, and the provisioning mechanism includes the shaping, the dropping, policing. All these mechanisms are required or implemented in Diffserv, which ensures that the packets which should get priority are given priority. Now in case of Diffserv model, the edge nodes, they will classify, and the core nodes, that is the routers which are there in the core of that network, they will be providing the aggregate behavior or a specific type of service to these packets. And this specific type of service is also known as per hop behavior. So we try to give a specific treatment to a packet depending on the class of a packet. So if there are different packets which are entering a router, we can see that a router can classify, and the packets can be marked with different colors. So the marking with the different color will ensure, will make the router know that this specific packet which has been marked with a different color needs a different treatment. So we talked of a mechanism called classification. So these are the different mechanisms which are used in Diffserv. So there is a process which is known as classifier, which classifies different packets. So the classifier is the first process inside a router which should be used to differentiate or to classify different types of packets. Once the packet has been classified, we also need to know whether the source or the host or the application, they are sending their packets at the agreed rates or not, whether they are crossing their limits. This means we need to measure whether the packets are being sent at the defined rate or not, and for that we are using a process called meter and which is used for marking the different packets. So if we know that, if we see that the packets from a specific applications are within the range, they are directly being shaped, and if not, then it is being sent to the marker. Now what the marker does, once the packet has been classified, now there is a need to color it. We had seen that there are different packets and these different packets would expect different treatment, and for that we are coloring them. Classification was a process which was allowing them to differentiate different packets. The marking allows a packet to be given a color. If we take an example, we have seen that in our roads, while using our roads for going from our home to the say from our office to our home, we see that the traffic, there is a lot of traffic and the roads are congested. Now in that case, we sometimes see that there is a car which is going with a red beacon on it, and most of the people, even the traffic police, will give a priority treatment to that car which is having a red beacon. So the marker is similar to putting a red beacon over your car. So if there is a packet which has been classified depending on the type of packet, you have been classified, and once you have been classified, then you are required to be marked with a different color, and that marking will be done by a marker. Once the marking has been done, now you need to give a specific treatment, and for that, giving that specific treatment, we have something called shaper or a dropper. Now shaper, if there is an application which is sending packets at a phenomenal rate, then this means this particular application will choke all the resources or will consume all the resources of the network. We don't want to do it. Now if we see that the application is crossing its limit, it is going beyond its negotiated profile, then we'll simply be dropping those packets. And we see that there are certain applications, say the voice application, where the different packets, they are having their jitters, different packets are facing jitters. So what we can do is we can buffer them, and at the receiving end we can expect that we can smooth that traffic by buffering them, so that the recipient, when it receives, it gets all the packets in order and it gets whatever it should. So the shaper will actually be giving the specific treatment to a particular packet. So it will either drop a packet or it will give a specific treatment to a packet. Now the Diffserv traffic conditioner, which we had just seen, it first classifies the incoming packets into predefined aggregates. There are certain categories which has already been made. So we don't have a lot of options, but we have been given the predefined categories. Then then we use the metering process, which is used to determine the compliance of the traffic parameters. And once it is there, then we mark them. We mark them by using one of the field in a IP header that is called DSCP, that is called Differentiated Services Code Point. And once it has been marked, we need to shape it. So either we buffer it or we drop it. Now the thing is, how do we classify? In IP header, there is a field called ToS field. Now the ToS field defines 8 bits. There are 8 bits in this ToS field. And please remember that this was the field which was given to us by the people who designed the internet in early 60s. So So this was the field which was used by the network for defining the type of service. Now in IP version 4, this field was known as this was having 8 different bits, 0 to 7, and initially they were using these 3 bits, the DTR, that is 3, 4 and 5. The 6 was not used initially. The DTR, that is the delay, throughput and the reliability, they were used, and at a later stage some people suggested that we should have one more field for defining the cost of it. So in the earlier version of IP header, the TS field was defined. Later the other researchers proposed that instead of having these type of service field, we should have another field which is called IP precedence field. This means we should define the priority of the packets. Now with this mechanism, now we were able to define priority of a packet. Now in this case, if we take an example and try to understand how it achieves the IP precedence, there is a network administrator who is having say the FTP traffic, the remote login traffic and the WW traffic, and he is giving the equal priority to both of the traffics. Now, and he is using IP precedence. Now when there is a congestion in the network, because both type of traffics have been given the equal precedence, what will happen? Either the login packets or the WW packets, they can be dropped because they are having the equal priority, but the network administrator does not want to drop a WW traffic, because that WW traffic may contain, say, may contain a packet which contains the transaction of a bank. So you would not like to lose that packet. But with this IP precedence, because the precedence is same, we don't have any control over it. So having this problem, people suggested that no, again there is a need to refine this type of service field, and people suggested that now we should have a DS field. And the DS field was differentiated services field. Again we were making use of that same type of service field, but now instead of those 3 bits or at another time 4 bits, now we are using 6 bits which are representing different categories, and we are not using 2 bits. So we are using 6 bits which are defining the different types of services which are being offered to different packets. Out of these 6 bits, there are few bits which are being reserved for defining the class selector code points. Now all the time the researchers have ensured that whatever they are offering, it has the backward compatibility with the previous versions. So the routers which are working on the IP precedence, if they are being asked to use the DS field, they should also be able to support the IP precedence. So for that, the 3 bits of the DS fields are being used. Now with this Diffserv classification, we come to the type of treatment which a packet should get, and the type of packet which a particular packet gets is defined by the per hop behavior. Now so we say that per hop behavior is basically an externally observable forwarding treatment at a single node. The PHB can be described in relative or absolute terms. PHB are typically implemented by means of buffer management and packet scheduling, and there are 4 classes which are available. There are 4 classes. One is called default, another is class selector, then we have expedited forwarding, and then we have assured forwarding. Now when we talk of default per hop behavior, that is the default PHB, this means we are talking of the same best effort treatment which the internet by default offers to the packets. So this means this DSCP also supports the best offer by using the default PHP. The another type of PHP which is being supported is called the class selector PHP, and as I had told you that this is used to provide backward compatibility to the quality of service. The third type of behavior is known as expedited forwarding PHP. Now, as the name suggests, it is expedited forwarding. That is, expedited means we are making things fast. So it ensures minimum departure rate. The minimum departure rate means it ensures or it guarantees the bandwidth, and it also policies the bandwidth. It checks whether the application is using the required bandwidth or not. Is it crossing that limit? And this type of treatment is good for any application which requires low latency, low jitter, assured bandwidth, and end-to-end service. The another type of forwarding treatment which a packet gets in Diffserv architecture is the assured forwarding. Now the assured forwarding, as the name suggests, it again guarantees the bandwidth, but it does not ensure the expedited behavior. So this is allowed for certain applications which can tolerate delays. So if there are applications which can tolerate delays, for them the assured forwarding will be used. The good thing about this assured forwarding is that it allows the additional bandwidth to be used if it is available. Now the assured forwarding, this itself defines 4 subclasses, and they are known as AF1, AF2, AF3 and AF4. And it is shown through AAA because we are using 6 bits, so they are in the form of AAA, 3 A's and 2 drop probabilities, and then there is a fixed 0. So within each class, as we had seen that there are 4 different classes, within each 4 class there are 3 drop priorities. This means which packet should be dropped if this particular priority packet are obtained. So we can see that there are 4 classes and there is a representation. So you can see that this bit has to be 0. The LSB of this field will always be 0 of DF for the DSCP. Will always be 0. These 2 bits are representing the drop probability. So 0, 1 all the time, if you can see in all the classes, it represents the low drop, and the 1, 1 it represents the high drop. This means if in this class if there are packets with the low drop and the high drop probabilities, then the packets with the high drop should be dropped first by the routers. Now what type of service the Diffserv offers? When we are talking of service, the PHBs which we are talking about, a customer doesn't see it. The customer will see what type of treatment a packet is getting. So it is defined with the help of service. So when we are talking of service, there are a lot of components which must work together. That is mapping of service to PHPs. We need to have conditioning of the traffic, we need to have the provisioning of network, or we need to have the forwarding which is based on the per hop behavior. And all these services which are defined, which are required in Diffserv, are defined in a service level agreement which is called SLA. So if at any time, if as a user, if you are going to your service provider and if you want to have a special treatment to the packets which are originated from your organization, then please go for SLAs. You need to sign SLA with your service provider so that he ensures that he gives the specific or special treatment to your packets. When we are talking of Diffserv, we talk of Diffserv domain. All these things, all these parameters, all these principles which we are talked about QoS are applicable in Diffserv domain. Now when we talk of Diffserv domain, the Diffserv domain is made up of an ingress node and egress node and the interior nodes. So all the boundary nodes which are at the entry point, they are known as ingress node. The node or the routers which are there at the outer end, they are known as egress nodes, and all the nodes which are there in the core, they are called the interior nodes. And we can also call these ingress and the egress nodes as the boundary nodes. Now let's see what happens, what type of treatment we give to the Diffserv. So if we see that there are 4 different applications which are coming from different hosts, there are 4 hosts. Out of these 4 hosts, 2 hosts are generating voice packets and 2 hosts are generating data traffic. So we can see that the IP Diffserv router, it will first classify these packets, mark these packets, and then give them a treatment, put them in a queue. This means the similar type of packets will get the same treatment from the router. So you can see that these voice packets, they are put in the queue for the class 1 and they are being given a specific treatment. Similarly, the data packets which may come from different devices, they are being given different treatment, and for that you can see that they are being kept in the class 2. So there are different classes which are being maintained in the network. So we can see that the boundary nodes, they perform these major operations, that is the classification and the conditioning. So in case of classification, it involves 2 operations, the classifier and the marker, which first classifies based on certain parameters like source address, destination address, source address port and destination port address, and the transport protocol, or it can also classify based on the MAC address. So there can be different mechanism of classifying the packets. Once the packets have been classified, they are required to be marked, and the packets are marked in terms of IP header field, which is known as ToS field, or in case of Diffserv, which is called DSCP. So the once packet has been marked, they are metered, and then several operations like shaper and dropper, they are being performed. So we can see that now for that instead of having the treatment for individual flows, the treatment for a specific class is given in these Diffserv nodes. So we can see that in this diagram the Diffserv architecture is shown, which indicates that there is an ingress router, there is an egress router, there is a core, there are different applications, different type of applications which are coming, there are different applications which are going to different resources. So we can see that the edge routers, the ingress router or the boundary routers, because they work usually at the lower rate, so we can have more functionality here, and we are trying to have the classification, marking and shaping done at these edge routers. The core routers, usually because they work at a very high rate, we can see that they are working at 100 Mbps or so. We would like to have the aggregate behavior being implemented at this. This means we are offering the per class service to these routers. Now let's see what are the advantages of the Diffserv architecture. We have seen that the Diffserv architecture, it does not require the resources to be booked in advance. So this, and because it does not book the resources in advance, so it does not require to maintain the states at every router. Because it is not maintaining the states of each and every flow, so it be scalable. It is highly scalable. It can support up to a number of 1,000 of connections can be supported, or 1,000 of different applications can be given quality of service treatment by the Diffserv architecture. This is very simple, and The good thing about the Diffserv architecture is it divides the load in different routers. That is, it does not expect every router to maintain a state and to perform the similar operation, but it divides the load. That is, at the edge router, as we had just seen, that at the edge router the classification and marking is being done, and at the core of the network we are trying to give the aggregate behavior to the packets of the similar class. And the good thing about the Diffserv architecture is it is easily adjustable with the service level agreement. So as a user, we have to ensure that we are signing SLAs with our service provider, and the service provider will ensure that the user gets the required services to its users. So in today's discussion, we talked about the quality of service in network. We talked about the definition of quality of service. We saw the history of quality of service in IP networks. We saw that from the beginning of the internet, the quality of service there was a provision for quality of service. We talked of different architectures, and very specifically we talked about Diffserv architecture, and we saw that the Diffserv architecture does not require reservations to be made in advance for the resources, but the resources can be availed while the packets are being transmitted or the packets are being routed from the source to the destination. We saw that this Diffserv architecture is a better option than the usual or the default behavior of the internet, which is best effort, and it offers better services to its users. I think I had to tell you this much about Diffserv. Thank you very much.